There's a particular kind of silence that falls over an airfield just before something historic. Not the dramatic, movie trailer kind of silence. The real kind. The kind where engineers who've spent 15 years on blueprints are standing on a tarmac in eastern Siberia, and the only sound is wind moving across a runway. Then engines. A narrow-body aircraft, slim-winged, clean-nosed, unmistakably modern, begins its takeoff roll. 30 minutes later, it lands. The crew reports nominal behavior. No anomalies. No surprises. And Russia's aviation industry quietly exhales. The aircraft was the Irkut MC-21-300. The flight was May 28, 2017. And what nobody fully understood that morning was that this was only the beginning of a story far more complicated than anyone had planned for. To understand the MC-21, you have to understand what Russia's aviation industry looked like in the early 2000s. It wasn't pretty. The Soviet aerospace machine, once genuinely formidable, had largely collapsed after 1991. Aeroflot was flying aging Tupolevs and Ilyushins alongside a growing fleet of Boeings and Airbuses. Russian carriers were buying Western jets, not because they particularly wanted to, but because the domestic alternatives simply couldn't compete on economics, range, or passenger comfort. The Tu-204 existed. The IL-96 existed, but their operating costs were punishing. Their fuel burn was high. Their interiors were dated. Maintenance costs were significant. Airlines made a rational business decision, and the Russian aerospace industry, once an empire, found itself increasingly irrelevant to the very carriers it was supposed to serve. The MC-21 was conceived as the answer to that problem. Not just a new airplane. Complete reset. The idea was to build a genuinely world-competitive narrow-body, something that could go toe-to-toe with the Airbus A320neo and Boeing 737 MAX on the metrics that actually matter to airlines: fuel burn, operating cost, passenger appeal, range. The program was organized under Irkut Corporation, part of United Aircraft Corporation, the state-owned consolidation of Russia's major aircraft manufacturers. From the start, the MC-21 was designed with a global supply chain. Pratt Whitney engines, Collins Aerospace Systems, Western Avionics, Western composite materials from Hexcel and Cytec. This wasn't naive. It was deliberate. Russia's engineers understood that certain components, particularly the high modulus carbon fiber used in the wing, weren't available domestically at the required specification. So they sourced globally, which at the time made perfect industrial sense. Here's the detail that makes the MC-21 genuinely interesting from an engineering perspective. The wing. Not just any wing, a composite wing wider, thinner, and aerodynamically cleaner than most single-aisle aircraft in its class. The MC-21 features a high aspect ratio composite wing manufactured using a process called out-of-autoclave curing. Most composite aircraft structures, the 787, the A350, use large autoclaves, essentially massive pressure ovens that cure the composite material under heat and pressure. Irkut's manufacturing partner, Aerocomposite, developed an alternative process using vacuum infusion and UV or thermal curing outside the autoclave environment. If this works as intended, and the evidence suggests it does, it represents a meaningful manufacturing advantage. Autoclaves are expensive. They're slow. They limit the scale of what you can produce. Out-of-autoclave composites, if properly controlled, allow for faster production cycles and lower capital costs. The MC-21's wing is wider than the A320's. It gives passengers a slightly wider cabin cross-section, 6 abreast, but with noticeably more shoulder room. This was a deliberate commercial choice. Boeing and Airbus had both made compromises on cabin width in the single-aisle segment. The MC-21's designers decided to differentiate on comfort. Not a trivial decision. On short and medium-haul routes, the bread and butter of any narrow-body, passenger experience matters to airlines trying to compete for fare-sensitive travelers. The composite materials for that wing, however, came from Western suppliers. Hexcel, Sci-tech, high-performance aerospace composites that Russia did not produce domestically at the required specification. This was the technical dependency that would later become a crisis. But in 2017, on that first flight day, it was simply the rational sourcing decision of a globally integrated program. Let's go back to that airfield in Irkutsk. The aircraft, tail number 73051, was crewed by two test pilots, Oleg Kononenko and Roman Taskiv, both honored as heroes of Russia. The sortie lasted approximately 30 minutes. The crew evaluated basic handling qualities, stability characteristics, and propulsion performance. They simulated approach configuration, conducted a low pass over the runway, climbed, executed coordinated turns, standard initial envelope expansion. Nothing extraordinary by test flight standards. But the significance wasn't in the maneuvers. It was in the fact that the aircraft flew at all. The MC-21 program had been through years of delays. The rollout ceremony, when the aircraft was first publicly revealed, was June 2016. Russian officials had been projecting a possible first flight even earlier in that year. It slipped. These things always slip. But the 2017 first flight meant that the core aerodynamic design was validated. The wing worked. The flight controls responded as modeled. The Pratt Whitney PW1400G engines, a variant of the geared turbofan that was also powering the A320neo family, performed within expected parameters. For Russian aviation, this was a moment of genuine industrial pride. Not nostalgia, not propaganda, real engineering achievement. The country had designed and flown a modern narrow-body aircraft with a composite wing, advanced avionics, and a next-generation turbofan. And it had worked on the first sortie. That's not nothing. In commercial aviation, maiden flights that go smoothly represent years of analysis, simulation, and manufacturing precision all coming together at the same moment. Then the world started to change. It didn't happen overnight. The first tremors came in 2018. Under the pressure of sanctions, initially related to the 2014 Crimea situation, but deepening through subsequent years, Western aerospace suppliers began reassessing their exposure to Russian programs. For the MC-21, this created a specific and serious problem. The composite materials for the wing, the avionics from Collins Aerospace, the engines from Pratt Whitney, all of these were sourced from companies operating under U.S. and European regulatory jurisdiction. You can debate the politics of sanctions all you want. That's not the point here. The point, from a purely industrial perspective, is this: Russia had built a genuinely competitive aircraft on a supply chain it did not fully control. And when that supply chain became uncertain, the aircraft's future became uncertain with it. The response from Irkut and United Aircraft Corporation wasn't panic. It was a pivot. A hard, expensive, technically demanding pivot, but a pivot nonetheless. The decision was made to redesign the MC-21 around a domestic materials and systems baseline. This gave birth to the MC-21-310. Same fuselage, same basic aerodynamic configuration, but with Russian composite materials, Russian avionics, Russian engine. The problem was that none of those Russian alternatives existed yet in production-ready form. They had to be developed, certified, and integrated into an aircraft that was already flying. The most significant single change in the MC-21-310 is the engine. The Pratt Whitney PW1400G, a world-class geared turbofan, was replaced by the Aviadvigatel PD-14. Let's talk about what that actually means. The PD-14 is Russia's first wholly new civil turbofan engine since the Soviet era. That's not a marketing claim. That's an engineering reality. For decades, Russia had been modifying, upgrading, and extending engine designs that traced their lineage back to Soviet programs. The PD-14 broke that pattern. It was a clean-sheet design, developed under the Perm engine company, Aviadvigatel, with significant involvement from Russia's CIAM Research Institute. The engine received Russian type certification in October 2018. That certification was itself a milestone. Russia hadn't certified a new civil turbofan in a very long time. Now, is the PD-14 competitive with the PW-1400G? Honestly, that question is still being answered. The PD-14's specific fuel consumption figures and overall thermodynamic efficiency are not publicly confirmed to the same degree as Western competitors. Russian officials have claimed performance parity. Independent aviation analysts have been more cautious. The PD-14 uses a turbofan bypass ratio and overall pressure ratio in the same general range as modern Western engines. But there are real questions about materials technology, particularly high-temperature turbine blade alloys, where Western manufacturers have decades of accumulated process knowledge. Closing that gap isn't impossible, but it takes time, and it takes testing. What's beyond debate is the strategic significance. If Russia can operate a modern commercial aircraft on a domestically produced turbofan engine, it has broken the most fundamental dependency in civil aviation. Every aircraft flies on its engines. If you don't control the engines, you don't control the program. The first flight of the MC-21-310 on December 15, 2020 wasn't just an aeronautical event. It was a statement about industrial policy. The engine was actually the simpler problem, because Russia had a baseline of turbine technology to build on. The composite material story was harder. Here's why. Aerospace-grade carbon fiber composite, specifically the high modulus, high-tensile type used in primary structure, is one of the most technically demanding materials in modern manufacturing. It requires precise fiber production, controlled resin chemistry, exacting manufacturing process parameters, rigorous quality assurance, certification against demanding fatigue and damage tolerance standards. Hexcel and Cytec, the Western suppliers originally specified for the MC-21 wing, had spent decades refining these processes. Russia's Umatex, a Rosatom subsidiary, was tasked with developing the domestic equivalent. That's not an impossible task, but it's not a quick one either. Carbon fiber production requires specialized precursor materials, high-temperature processing equipment, and process stability that can only be proven through extended production runs. The fact that Umatex eventually produced materials that could be certified for primary aircraft structure is a genuine industrial achievement. Whether it happened on the schedule originally projected, almost certainly not. Whether it required compromises in specification, that's still not entirely clear from public information. What is clear is that between 2019 and 2021, the MC-21 program underwent a materials substitution process that essentially redesigned the manufacturing baseline of the aircraft's wing. The geometry didn't change. The aerodynamics didn't change. But the materials, the manufacturing processes, and the certification documentation all had to be rebuilt from scratch. If 2018 was the first supply chain shock, February 2022 was the complete severance. Following Russia's invasion of Ukraine, Western aerospace companies, Boeing, Airbus, Pratt Whitney, Collins, GE, suspended all Russian programs and parts supplies. For the MC-21, this meant that any remaining Western content in the avionics, electrical systems, flight control computers, and onboard computing architecture had to be replaced. Not gradually, immediately. This is where the MC-21 story becomes something genuinely unusual in aviation history. Most aircraft programs experience supply chain disruptions. Most aircraft programs face certification delays. Some aircraft programs get canceled. But very few aircraft programs in the modern era with a modern certification standard have been comprehensively redesigned mid-development to eliminate virtually all foreign content. The 2022 sanctions wave meant that Russia had to develop or locally source avionics computing hardware, flight management systems, air data systems, communication and navigation equipment, electrical generation and distribution systems, hydraulic components, braking and ground systems. The list is long, and for each system the process is the same. Design it, build it, test it, certify it, integrate it into the aircraft, recertify the integrated configuration. This explains why the MC-21's entry into commercial service has continued to slide into the late 2020s. It's not that the basic aircraft doesn't work. The MC-21-310 has been flying with the PD-14 engines since 2020. It's that the certification process for the comprehensively localized configuration, with all Russian avionics and systems, requires an enormous amount of flight test validation. Every system change requires data. Every data point requires flight hours. Here's something worth explaining. When aviation programs talk about certification, they're not talking about a rubber stamp. They're talking about a structured, legally binding demonstration that an aircraft meets defined safety standards across its entire operating envelope. For a new aircraft, this means thousands of flight test hours, hundreds of individual test points, defined airworthiness criteria for every system, flutter testing at limit airspeed, stall testing across configuration matrix, engine failure demonstrations, icing certification, electrical system failure cases, emergency descent profiles, evacuation certification for the cabin. Now imagine doing that, and then changing half the avionics. You don't just update the software. You rerun the system-level tests. You redemonstrate the failure cases. You recertify the human-machine interface. You generate new flight manual data. This is what the MC-21 program has been doing since 2022, running a certification campaign for an aircraft that keeps getting new components. And here's the additional complication. Russia's certification authority, the Federal Air Transport Agency or Rosaviatsia, is no longer pursuing EASA validation or FAA recognition. That door has been functionally closed by the geopolitical situation. So the MC-21 will initially enter service certified only for Russian operators. That's a significant market limitation. Not fatal. Russia's domestic aviation market is large enough to absorb meaningful MC-21 deliveries. But it means the aircraft cannot, for now, be sold to airlines in most international markets. Let's talk honestly about what this costs. Building an aircraft is expensive. Boeing spent somewhere in the range of $30 billion developing the 787 Dreamliner. Airbus spent a comparable figure on the A380. Those are programs with global supply chains, decades of institutional knowledge, and full access to the world's most advanced aerospace materials. The MC-21 has been developed with significant state funding. Russia's government has consistently supported the program as a matter of industrial policy. But the costs of the localization program, the composite materials, the PD-14, the avionics replacement, have been additive to the original budget. Every redesign costs money. Every recertification costs flight hours and engineering labor. Every domestic supplier relationship has to be built with significant upfront investment before a single component is shipped. The economics only make sense if you think about it strategically. If Russia can eventually produce the MC-21 with fully domestic content, controls its own aerospace capability, it doesn't depend on foreign suppliers that can be sanctioned. It retains the engineering talent to maintain and evolve the program. It can potentially offer the aircraft to markets that are outside the Western sanctions framework, countries in Asia, the Middle East, Africa, Latin America that might prefer an alternative to Boeing and Airbus. That's the long game. Whether it plays out that way depends on whether the MC-21 can achieve the production rates and unit economics to compete on price, and whether Russian industry can execute at the required scale and quality consistency. Those are serious questions. The supply chain is still being built. The manufacturing base is still being proven. As of the mid-2020s, the MC-21 program has multiple aircraft in the flight test fleet. The PD-14-powered MC-21-310 has accumulated meaningful test hours. The fully localized configuration with Russian avionics and systems is working through its certification campaign. Yakovlev, the newly branded successor entity within UAC, has outlined production targets for the late 2020s. These targets have been revised downward from earlier projections. Original plans imagined delivering dozens of aircraft annually by the mid-2020s. Reality has been more constrained. Aeroflot, Russia's flag carrier, remains the primary launch customer for the MC-21. The airline has maintained its commitment to the program under difficult circumstances. It has also had to adapt its entire fleet strategy following the 2022 sanctions, which left it holding hundreds of Western-leased jets that it could no longer legally maintain with Western parts. The MC-21, in that context, isn't just a new airplane for Aeroflot. It's part of a fundamental restructuring of Russian civil aviation around domestic technology. S-7 Airlines, Rossiya, and other Russian carriers have also been identified as potential MC-21 operators. The domestic market need is real. Russia's airlines need new airframes. Their existing fleets, increasingly maintained through gray market channels and cannibalizing retired aircraft for parts, cannot sustain indefinitely. The pressure to get the MC-21 into service is genuine. It's worth pausing here to compare two parallel stories. Russia's MC-21 and China's COMAC C919 are often mentioned in the same breath. Two large countries trying to build narrow-body aircraft to challenge Boeing and Airbus. But the strategies have been different. The C919 was developed with a fundamentally different approach to foreign content. COMAC deliberately retained Western avionics, systems, and engines, specifically the CFM LEAP-1C, as the certification baseline. The logic was, get the aircraft certified to international standards with trusted Western systems, then incrementally develop Chinese alternatives over time. The MC-21 began with a similar logic: use best available global components, demonstrate the aircraft's performance, then build domestic capability alongside. The difference is that China's program has not been subjected to the same level of supply chain severance. The C919 is currently operating in commercial service with Chinese airlines, using Western engines and avionics. The MC-21 has been forced to pursue localization much faster than planned, under much more difficult conditions. Neither strategy is obviously correct. China's approach left it dependent on Western suppliers who could theoretically impose restrictions in the future. Russia's forced localization has created a genuinely independent capability, at enormous cost and delay. What the comparison reveals is how deeply modern commercial aviation is embedded in global supply chains, and how costly it is to exit those chains under anything less than ideal conditions. Somewhere in this story, it's worth remembering the people actually doing the work. The engineers at Irkut and Aero Composite, the materials scientists at Umatex, the propulsion team at Aviadvigatel in Perm, the avionics engineers working on Russian-developed flight computers. These are people who have spent their careers on a program that has been redesigned around them, sometimes more than once. Russian aerospace engineering talent is real. It's not a talking point. The country produced Tupolev, Ilyushin, Mikoyan design bureaus that created some of the most technically interesting aircraft of the 20th century. The Antonov and An-24, the Tu-160, the Su-27 family. These aren't imitations of Western designs. They're original engineering solutions to defined operational problems. The MC-21 team comes from that tradition. What they've been asked to do, rebuild a civil aircraft program from the ground up under sanctions in compressed timelines, is genuinely difficult. Not impossible, but difficult in ways that don't show up on program schedules. The accumulated knowledge to reliably manufacture aerospace-grade composites at scale doesn't transfer through a government directive. It develops through production experience, through understanding failure modes, through solving problems that only appear at volume. That process takes time. So what is the MC-21 in the final analysis? The several things simultaneously. It's an aircraft, a genuinely well-designed narrow-body with a competitive aerodynamic configuration, a modern composite wing, and a next-generation domestic engine. It's an industrial project, the most ambitious attempt in decades to rebuild Russia's civil aerospace capability from the ground up. It's a geopolitical statement, evidence that under sufficient pressure, a large industrial nation can decouple from global aerospace supply chains. And it's a case study in what happens when technology programs are built on supply chains they don't fully control. The questions that remain are practical ones. Can Russia produce the MC-21 in the volumes its airlines need? Can the program's unit economics be competitive enough to win orders outside Russia? Can the domestic avionics and systems meet the reliability standards that airline operations demand? These aren't rhetorical questions. They're answered through years of airline operations, maintenance records, and dispatch reliability data. None of that data exists yet. That morning in Irkutsk in May 2017, the people on the tarmac thought they were watching the beginning of a straightforward success story. Russia had built a modern aircraft. It flew. The engines worked. The wing was beautiful. What they couldn't have fully anticipated was that the aircraft they were celebrating would spend the next decade being essentially rebuilt. Not because the design was wrong, but because the world around it changed.
Sanctions.
Supply chain severance. Geopolitical fracture. These aren't engineering problems. They're political ones. But they land on engineers. They land on production floors. They land on certification schedules. And they land on the airlines waiting for new jets that keep getting pushed to the right. The MC-21 will eventually enter commercial service. The question isn't really whether, it's when and in what form and for how many operators. What it will represent when it does is something rarely achieved in the modern era. An aircraft built under maximum industrial pressure, on a supply chain that had to be invented as the program ran. That's not a story about geopolitics. That's a story about what engineering actually is. Not elegant drawings on a white wall. Not CAD models and simulation runs. Engineering is what happens when the world stops cooperating and you have to build it anyway.